All right, guys, you should have this pulled up. It says exponentials and logs, all right? This is not an actual section of the book or anything, but this, remember our little cheat sheet that I put together for you for rationals? This is similar to that. This is the most centralized way I could get you to see the similarities and differences between these two functions. Okay, we talked about how to find the transformations within, which we'll talk about. We talked about evaluating, like if I said to you evaluate, you're just plugging in for x, that sort of a thing. So now we're going to talk about domain and range and asymptotes. Remember, asymptotes are those lines, vertical, horizontal, that functions get really, really close to, but don't actually touch. They're like those boundary lines. We are not going to physically graph any of these. You guys are not going to have to graph and plot points, but we are going to start talking about logarithmic functions next week, and we're going to start solving these things. So you need to understand the happenings and the what makes them up and what makes them similar and what makes them different. But what I want you guys to see, right, on the left-hand side, I have exponential functions. See that? On the right-hand side, we have logarithmic functions. In the middle, in the pink, it says that they are inverses of each other. What does inverse mean? Opposite. So a lot of things that ring true for exponential, it's the exact opposite in logarithmic. So this is where I want you guys to rewatch this weekend. We're going to keep coming back to stuff like this. Anything that rings true with exponentials, it's the opposite when you go to logs. So an exponential function, remember, an exponential function has a variable in the exponent. If the base is bigger than 1, it's a growth. If the base is between 0 and 1, it's a decay. Everybody understand that? Okay. A logarithmic function looks like this. What do you notice? What words do you see in the logarithmic function? Log or ln. On your calculators, we talked about this yesterday. When I would tell you guys to evaluate, when you got the E, to get the E to come up, you had to hit the second what button? ln, right? E and ln are what of each other? Inverses. Exponentials and logarithmics are just inverses of each other. So similar to a parabola. When I talked to you guys about parabolas and quadratics, we talked about domain. What was the domain for every single quadratic or parabola we ever talked about? Negative infinity, positive infinity. The domain for every single exponential function is negative infinity to positive infinity. All the ones that we're going to do. Now, when we talk about the inverse, what's the opposite of domain? Range. So if for exponential functions, the domain is always negative infinity to positive infinity, it should make sense that for a logarithmic function, the range is negative to positive. Do you see how I have that highlighted? They're opposite of each other. They're inverses. An exponential function is going to have a horizontal asymptote. What kind of a line is a horizontal line? Horizontal. What does that look like? Left to right or up and down? Left to right. It's a y equals. So if an exponential function has a horizontal asymptote, what does the logarithmic function have? A vertical asymptote, one that's up and down. It's going to be an x equals. All right, we're going to find y-intercepts. We'll find y-intercept for logarithmic next week. But to find the y-intercept, guys, of an exponential function, you just plug in 0 for x. Very simple. You guys can do that. And then when we talk about range, okay, range is always going to be based upon your asymptote. It's only going to be two different things. It can either be negative infinity to the asymptote or asymptote to infinity for both things. One just goes up and down, and the other one's left to right. It's always going to be based on the asymptote. Question. The question was, are there going to be any unions with our domain? It's not going to be. It's either going to be negative infinity to the asymptote or the asymptote to the infinity. It will never include the asymptote, so you always have a parenthesis. Now, on your little cheat sheet for exponential functions, what did I write? How do you find the horizontal asymptote?
Y equals.
Y equals what?
The vertical
The vertical shift. That's it. You guys can look at every single equation and tell me in an exponential function what the horizontal asymptote is. It's whatever's being added or subtracted to the end of your function. To find the vertical one in a logarithmic, you set whatever's in parentheses equal to 0. Similarly, remember with our rational functions, we set the denominator equal to 0? It's kind of the same thing. What went hand in hand? When you found the vertical asymptote, what else could you find?
The domain.
Same thing goes for logs. So this is not really a difficult concept other than you got to think a little bit. Let's look at number 1. All right, I'm going to ask you all of these things. I'm going to say, what's the domain, the range, this and that? What is the domain for every single exponential function we're ever going to talk about? Negative infinity, good, to positive infinity. Now we'll talk about range in a second, but you can already tell me what the horizontal asymptote is. Y equals what? 7. It's whatever the shift is. How would we find the Y-intercept? Plug in 0 for x, okay? Some of you guys are like, oh, I gotta get my calculator out. No, you don't. Negative 2 to the 0 power plus 7. What's anything to the 0 power?
1.
So this is negative 1 plus 7, which is 6. We always write our intercepts as ordered pairs. So when I plugged in 0, I got out 6. Terribly difficult. No. All right. Now this is where we have to think. This is very, very similar to how we found our range for our parabolas. Remember, if we had a negative parabola, our domain was negative infinity to whatever the y part of the vertex was, right? I mean, our range, I'm sorry. And then if it was a positive one, it was the y part to what? Positive infinity. This function is going to flip over the x-axis, correct? It's going to go from the top and flip where? To the bottom. So is this a negative in our mind or a positive?
Negative.
A negative. So is my range going to be from negative infinity to the asymptote or from the asymptote to infinity? Negative infinity to the asymptote. Perfect. Very good, guys. Let's look at 2.
Why would it be 7?
Because that's our horizontal asymptote. That's our boundary line. Now, you guys will have a question on your quiz that says, given this exponential function, tell me all of the transformations. Okay, let's just run through this real quick. What does this 5 out in front mean? Oh, what kind of a stretch? Vertical, horizontal? Vertical stretch, good. What about this plus 1 inside the exponent? Left 1, very good. And what does this minus 6 at the end mean? Down 6. Is this a growth or a decay? How do you know that? Not because it's down. What's the base? Is it bigger than 1 or is it between 0 and 1? The base? 1/3? It's a decay because it's between 0 and 1. Okay, so this is an exponential function. What is the domain of every single exponential function we're ever going to talk about? Negative infinity, good. To positive infinity, give me 1 sec, Sarah. What is my horizontal asymptote? Just by looking at this. Y equals, right? Negative 6. How would I find the Y-intercept? Plug in 0 for x. Okay, so let's do that. We got a little bit of work to do here. I'm going to say 5 times 1/3, 0 plus 1 minus 6. What is 0 plus 1? So I have 5 times 1/3 minus 6. Multiply 5 and 1/3, you get 5 over 3 minus 6 over 1, right? Can I subtract those two? Got to get a common denominator. What's the common denominator between 1 and 3? Good, this would be 3. So then I change this to 18 because 6 times 3 is 18. And then what's 5 minus 18? Negative 13 over 3. So my y-intercept is at 0, comma, negative 13 over 3. Again, I'm not having you graph this. Now look at this function. Is this a positive function or a negative one? Positive. So is my range going to be from negative infinity to the asymptote or from the asymptote to infinity? Asymptote to infinity. Good. Sarah, what was your question? All right, we'll go to the next examples in a second. Let's go over here to logs. Remember, logs and exponentials are what of each other? Inverses. So now instead of when we talk about range, stuff being from bottom to top, we're talking left to right. Okay? What is the range for every single logarithmic function we're ever going to talk about? Negative infinity to positive infinity. Good. Now, what goes hand in hand? When I find one, I'm actually finding the other as well. The vertical asymptote and domain. To find the vertical asymptote, we set the parenthesis equal to 0. So 2x minus 3 equals 0. 2x equals 3, so x equals what? 3 over 2. So x equals 3 over 2. That boundary line that my graph gets really close to but doesn't touch is 3 over 2.
You don't have to write as oral pairs.
No, not asymptotes, no. So now you have to have x equals or y equals. So now we're thinking domain. We're thinking left to right. Is this a positive function in terms of left to right? What axis would it have to flip over for it to change left to right? No, the y-axis, right? Over here, I had to worry about a reflection over the x-axis, top to bottom. Over here, I need to worry about if there's a reflection left to right. Where is a reflection over the y-axis? Is it out in front or is it inside with the x? It's inside with the x. So look here. Is there anything inside with that in front of 2x that says, ooh, it flipped to the other side? No. So then your domain is going to be from the asymptote to infinity. If it was on the other side, if it's a negative, that's when it's like from left to the asymptote. So you just got to see. Say it again. Yes, correct. So immediately you guys see a negative, so you're like, oh, it flipped. Where did it flip? From top to bottom or left to right? No. Top to bottom. So it doesn't change. It does not change the domain. It does not change anything. It just went from top to bottom. But we don't worry about that. We worry left to right when we talk about logs. So what is the range for every single log we're ever going to talk about? Negative infinity to positive infinity. Good. How do I find my domain? Set what equal? Parenthesis. Good. X plus 6 equal to 0. When I find my vertical asymptote, I also find the domain. So x equals negative 6. X equals negative 6. Is this a positive inside or negative? Inside. Look, this graph, instead of looking like this, it flips over the x-axis, so it looks like this. Did it switch from one side to the other, left to right? No. So then your domain is just going to be asymptote to infinity. It's still over here on the right-hand side. Remember, everything is opposite. So with an exponential, if it's negative out in front, God bless you, it switches. With a logarithmic, if it's negative inside, it switches. God bless you. Let's do these last two. All right, let's talk about this function. Tell me, answer my questions. Is this an exponential function or a logarithmic function? Exponential. I know it's exponential because there's a variable in the exponent. If it was a log, it would have the word log or natural log in it. Is this function a growth, God bless you, or a decay? It's a growth because the base is what? Greater than 1. What does that 2/3 out in front mean? That's a vertical shrink. Good. What is this negative here? Tell me. Reflects over y. Okay. Does that matter to me if it's an exponential? No. And what does this 2 mean? It's a horizontal shrink. Very good. Opposite of what you think. Good. So, guys, let's go through our characteristics. What is the domain of every single exponential function we're ever going to talk about in our entire life? Good. Negative infinity to positive infinity. Now, that horizontal asymptote, I can just look and see what it is. What is being added or subtracted right here? Is there anything? So it's 0. It's not none. It's 0. How do you find the y-intercept again? Plug in 0 for x. Oh, geez. You guys got your calculators? Do you really need them? Before you freak out, guys, plug in 0 for x. Well, what's 0 times negative 2? 0. What's anything to the 0 power? 1. Where's your y-intercept? At 0, comma, 2/3. Very good. Now, let's talk about our range. It's either going to be negative infinity to our asymptote or the asymptote to positive infinity. Asymptote to positive infinity. 0 to infinity, because this is a positive function there. Question. All right, scoot on over here. What kind of function we talk about here? Logarithmic or exponential? How do you know? It says the word log. Okay? You guys got that? What is going to be negative infinity to positive infinity every single time we talk about logs? The range. Very good. What goes hand in hand when I find one and I find the other? Domain and vertical asymptote. Great. So I'm going to set my parenthesis equal to 0. So negative 5x equals negative 9. Divide by negative 5. X equals 9 over 5. Correct? So x equals 9 over 5. Now think about this. Is it left to right, negative infinity to my asymptote, or is it asymptote to positive infinity? This tells you right here where to start. Negative infinity to the asymptote. It flips over the y-axis.